Get on my head. Get on my head. Get on my head.
Hello everyone, I am Gaurav, and in this video we are going to talk about Quicksort algorithm with time efficiency methodology of Quicksort algorithm. First we need to choose a pivot. Select a pivot from the array. The choice of pivot can vary. It can be the first element, the last element, the middle element, or can be a random element, but its efficiency can be affected by the choice of pivot. Partitioning. Rearrange the array such that all elements less than the pivot are on the left of the pivot and all the elements greater than the pivot are on the right. The pivot is now in its correct sorted position. This step is usually done using two pointers that start from both the end of the array and move towards each other until they meet. You can take I and j and we can start the Quicksort algorithm. Recursively apply the above step. Apply the same process to the left subarray element that is less than pivot and the right subarray elements that are greater than pivot. Base case. The recursion stops when the subarray have 0 or 1 element as they are already sorted. Algorithm. Main Quicksort function. This function takes an array, the starting index low and the ending index high as parameters. It sorts the array in place. Partitioning function. This function takes an array and two indices, low and high. It selects a pivot element, partitions the element around the pivot, and returns the index of the pivot element after partitioning. And here is the algorithm. First we need to take a Quicksort function which has array and low and high. If it is low, if low is less than high, then p of I equal to partition array low and high, and the Quicksort is like array then low and then p of I minus 1. Otherwise Quicksort is array and p plus 1 and high. Now we have to take another function, that is partition function, which is used to partition the array in two different parts, which is less than pivot and other is higher than pivot, greater than pivot we can say. It also has array and low and high function. Pivot is equal to array of high and I equal to low minus 1. For j equal to low to high minus 1, if array of j is less than or equal to pivot, then I equal to I plus 1, means the position of I shifted to the next value, or then we will swap the value I and j. Then again we will use the swap value with incrementing I plus 1 and high, and then we will return the value I plus 1. Now we will take another function, that is swap function, having I and j, and we will use a temporary, that is array of I equal to array of I, and array of I equal to array of j, and array of j equal to temp. So these three functions we will use in Quicksort algorithm. Now here we can see one example which has 10, 80, 30, 19, 40, 50 and 70 is a set, and we need to use the Quicksort algorithm here. First we will partition around 90, that is last element, and then the partition of 10, 30, 40 and 50 which are less than 70 will be on one side, and 80 and 90 which is greater than 70 will be on the right side. Now again we will partition around 50, that is the last element, and 30, 40, 50 which is less will be on the left side, and there is nothing which is greater than 50, so it will be vacant. Then again we will partition around 40, so 10 and 30 will be on left side, and nothing will be on the right side. Then we again partition around 30, so 10 on the left side. On the right hand side we will partition around 80, so it will go on left side, and 90 will go on right side. So the sorting like 10, 30, 40, 50, 70, 80 and 90 sorting is this. That is the sorted array, which is 10, 30, 40, 50, 70, 80 and 90. This is sorted array. Analysis. Time complexity. Best case is n log n, average case is also n log n, and the worst case is n square, because it will take more time to solve any problem using quicksort algorithm. Best case. The best case occurs when the pivot divides the array into two nearly equal halves at each step. This results in a balanced partition, leading to a recurrence relation similar to merge sort. That is, time complexity is equal to 2t n square plus n and tn. Solving this recurrence relation gives us time complexity equal to n log n. Now we have the average case. In the average case, the pivot generally splits the array into two sub arrays of roughly equal size. The average case time complexity can be derived using a similar recurrence relation as the best case, that is n log n. Now the third one is worst case. The worst case occurs when the pivot always picks the smallest or the largest element, resulting in highly unbalanced partition. For example, if the array is already sorted or sorted and we choose the last element as the pivot, the partition size
మద్యం సేవించడం ఆరోగ్యానికి హానికరం.
would be
Consumption of alcohol is injurious to health.
worst case. The worst case occurs when the pivot always picks the smallest or largest element, resulting in highly unbalanced partitions. For example, if the array is already sorted or reverse sorted and we choose the last element as the pivot, the partition sizes would be 0 or n minus 1. This leads to the recurrence relation, that is t of n minus 1 and o of n. Solving this recurrence relation gives us time complexity as n square. So here we can see best case and average case is same, n log n, but the worst case is n square. Now we will see the program. Here we can see we are using a swap function, a partition function, and a quicksort function, which is earlier we have seen in here in the algorithm section. We have seen these three functions: quicksort, partition and swap. Using these three functions, we are here writing a program which is used for quicksort. You can see we have used swap, p1 and p2, and then we have used partition low with array and low and high. Same you can see here in quicksort. We have taken an array with low and high, and we have checked if low is less than high, then we have done partitions. We have used quicksort algorithms, and at the last we have given an array that is 10, 7, 8, 9, 1, 5, and we have checked all these things. Now based on the algorithm, we have done the quicksort algorithm, then print. We have printed whatever the array we are getting, the sorted array we are printing here, and now in the output you can see the sorted array is 1, 5, 7, 8, 9, 10. Detailed examples. Now consider array 10, 80, 30, 90 and 40. Compare 10 with the pivot and as it is less than pivot, arrange it accordingly. Now we are taking here 40 as a pivot, and we are checking if it is less than 10 or greater than 10. If it is greater than 10, then we will swap it. Now compare 80 with the pivot. It is greater than pivot, so there will be no swap, as the pivot is less than the number. Compare 30 with the pivot. It is less than pivot, so arrange it accordingly. Now we are comparing 30 with the pivot, and as we can see 30 is less than pivot, so we will swap it. Now compare 90 with the pivot. It is greater than pivot, so there will be no any swap function. Arrange the pivot in its correct position. Here we can see we have arranged the pivot in its correct position. We have swapped 80 with 40, so 40 will come in the middle of, so that the number left on the left side of the pivot will be less than, and the number with right side of the pivot will be greater. As we can see here, 40 is between 10 and 30 on the left side, and 80 and 90 on the right side. Illustration of quicksort. As the partition process is done recursively, it keeps on putting the pivot in its actual position in the sorted array. Repeatedly putting pivots in their actual position makes the array sorted. Follow the below image to understand how the recursive implementation of the partition algorithm helps to sort the array. Initial partition on the main array. Here we can see 10, 80, 30, 90 and 40. Partition around 40 means pivot will come in the middle. Now partitioning the subarray. We will now partition the subarray, that is 10 and 30, for checking which is coming first, either 10 or 30, and then we will arrange it properly in sorted array. Now we will also check 80 and 90, and then we will sort it, and after that we will arrange in a proper sequence, that is 10, 30, 40, 80 and 90. Advantages of quicksort. Efficiency. On average, quicksort has a time complexity of n log n in place. It does not require additional memory proportional to the input size. Divide and conquer. Simplifies problem solving by breaking down the problem. Disadvantages of quicksort. Worst case performance. In the worst case example, already sorted array with poor pivot choice, the time complexity can degrade to n square. Not stable. Quicksort is not a stable sort, meaning it does not preserve the relative order of the equal elements. By carefully choosing the pivot and using techniques like randomized quicksort, the worst case performance can be mitigated. And one thing we have to note, that quicksort is based on divide and conquer, means first we will take a array, then we will divide it, meaning pivot will be in the middle, and the left side is smaller than pivot and right side is greater than pivot, means we are dividing it in two parts, dividing the array into two parts, and then we are one by one conquering and getting our sorted array. Applications. First one, commercial computing is used in various government and private organizations for the purpose of sorting various data, like sorting files by name, date, price, sorting of students by their roll number, sorting of accounts profile by given IDs, etc. Second one is, the sorting algorithm is used for information searching, and as quicksort is the fastest algorithm, so it is widely used as a better way of searching. Third one, it is used everywhere where a stable sort is not needed. Fourth one, quicksort is a catchy, friendly algorithm, as it has a good locality of reference when used for arrays. Fifth, it is tail recursive, and hence all the call optimization can be done. Sixth, it is an in-place sort that does not require any extra storage memory. Seventh, It is used in operational research and event driven simulation. Numerical computation and in scientific research for accuracy in calculations. Most of the efficiently developed algorithm uses priority queue, and Quicksort is used for sorting. Ninth one is variants of Quicksort are used to separate the kth smallest or largest elements. 10th one, it is used to implement primitive type methods. And the last one is, if data is sorted, then the search for information become easy and efficient. Thank you. Have a nice day.